Hello, good morning everyone. It's me Pankaj Sharma from Gaiga to Deepur. Today I'm going to present all about the next generation battery. So would you please guess what can be the next generation battery? If you think that lithium ion battery is the next generation battery, then absolutely you are just closer to the answer, but not, it is not. Now, in the era of next generation, there must be possible AI advancement with altogether advancement in the battery management system also. So the next generation battery could be the CEQLM-12X, the most advanced battery in the next generation and next era. So let me introduce what is CEQLM-12X. CEQLM-12X actually represents the covalent enhanced quantum lattice matrix 12X, which is designed as a platform technology for the next generation energy storage. Oh my god, it's the next generation. And actually, you may have the question about the 12x. What does this represent? Yes, 12x actually represents the number of electrons flowing at once from the battery to the desired place. So it means that lithium ion battery actually has the only two electrons flowing from it, flowing through it. But silicon 12x provide the facility of 12 electrons per times. Okay, so here what can be the target capacity of this silicon 12x? Silicon 12x actually has the capacity of 3000 to 4000 watt hour per kg. So actually what is this? If you say what actually is this? So 3000 to 4000 watt hour per kg by 2028 the target will be hit, means the energy density capacity of the silicon 12x will be 3000 to 4000 watt hour per kg. It means that if you have 1 kg of potato, if you have 1 kg of potato or 1 kg of metal, just like lithium ion battery having 1 kg means this small size, and what could it produce, how much current it will generate, how much voltage it will supply. So almost 2 to 3 volt, and may have a small number of capacity. And lithium ion battery actually has the capacity of 250 watt hour per kg. Now can you see the difference between the lithium ion battery and the silicon 12x? Obviously there is a huge, that's 10x, 10x not, it's all about 15x, 15 times greater than the lithium ion battery. So where are the applications of the silicon 12x? Silicon 12x will be applied for the EVs, electric vehicles, robotics, power grid, inverter, and the aerospace satellite powering up for a long run. So where it will be integrated? The SOCOM 12X will be integrated with the AI-driven process control for the repeatable synthesis. So let me tell you that the SOCOM 12X has the advanced battery architecture for the dynamic environments. So here is no mechanism sought uh, for the development and actual manufacturing process. But here are the key points where silicon 12X integrates with solid state lithium chemistry. It means that the solid state lithium chemistry, no liquid. Actually, you can see in the mobile laptops and EVs contains the liquid lithium, which produces a lot of heat, which is responsible for the production of a lots of heat, which cannot tolerate up to the 80 to 100 degrees Celsius heat. So it is far more dangerous, and the silicon 12X is viable and reliable for the conditions since it has 10 to 20% heat production only. So here, designed to deliver adaptivity, thermal stable, yeah, I have already told you, and a high cycle performance. So application domains, EVs, robotics, AI integrated device, and the intelligent grid systems. So let me jump to the next one. Here, lithium. So here is the brief differentiation between the lithium ion versus silicon 12X quintics. So quintics is a name given to the silicon 12X by myself. Okay. So here, properties. What can be the properties of the both types of battery? So here are the property distribution for those battery, and here chemistry base. On the basis of the chemistry, lithium ion means lithium metal is used inside the battery, and for the silicon battery, there will be use of lithium plus silicon means covalent enhanced quantum lithium lattice matrix, which is 12x CuF. I don't know actually what CuF actually represent, but I will tell you later. So charge time, it will actually require, means what? Lithium ion battery will actually require 90 to 120 minutes to charge the 80 to 80%, up to 80%. And the silicon 12X will actually require the 10 to 20 minutes. Actually, it's 10 to 15 minutes, but it will actually acquire 10 to 20 minutes. And here the life cycle durability, 2000 to 3000 cycles only. What does this mean? This will be only used for 1 year to 2 year, but here is 10,000 cycles. It means it will be running for a long time. It means it has silicon 12X has the longevity, and it provides the durability to the consumer. Here, energy density. How much energy density does actually a lithium-ion battery has? It has, and the latest lithium-ion battery has about 280 to 300 watt-hour per kg, and the Tesla Model S or Model X EVs are using 280 to 300 watt-hour per kg since they are at the top companies. But so comfortable X will be producing or having the energy density of 1200. This I have already told you 3000 to 4000 watt hour per kg. So operating temperature range, here is, yeah, this you may see that minus 10 degrees Celsius to the plus 60 degrees Celsius, but here no, minus 40 degrees Celsius. So it has lower temperature density, temperature range to the 80 degrees Celsius. So if you see that there is increase, but there is no liquidity, which liquid actually, what the liquid actually do? Liquid actually produces the dendrite inside the battery, which is responsible for the short circuit, and there is a of the battery, blasting of the battery, okay, which is responsible for the all lots of accident. Here is healing mechanism. Okay, healing mechanism property is not acquired by the lithium-ion battery, but self-repair, something here is written, is acquired by the silicon 12X. Similarly, modulation capability, fixed output. Only fixed output means what? If the battery produces the 12 volt, then it will only produce the 12 volt. Where adaptivity, it means that if with respect to time, if there is any changes or any upgradement available, then it obviously increases the level of voltage supply. Hey, so tidal systems is system level integration. Yeah, actually, what system level integration include is embedded microcontroller inside the battery handles thermal regulation. Yeah, okay. Obviously, thermal regulation is the most important thing inside the battery, which is responsible for the heat regulation, discharge scheduling, and the diagnostic logic. Sensor may read vibration, heat, and the electrical pulse patterns used for the responsive modulation. Yeah, obviously, the sensors used inside the battery will actually determine and produces the feedback to the consumer or to the first system. Okay, here graphene diffusers and the nano channel cooling system maintain consistent temperature gradients. Okay, is used to maintain the temperature gradients, so which is actually maintaining the constant stable temperature. So here is a lab. So engineering with the precision, not promises. Yeah, actually, Celcom 12X actually is engineered with the precision, not promises. Okay. Here, what Celcom 12X bridges with? Celcom 12X bridges with the gap between the physics-driven design and the adaptive energy logics without the needing miracles, just chemistry behaving wisely. Yes, there is actual advancement in the chemistry, and we have used inside the Celcom 12X. So at the end, I want to say you this was my presentation. I hope you liked about it. And hey, do you have any question? If not, then if no question, thank you. You can email us at the Pankaj Kumar Sharma at 79 at the gmail.com. So there is a dot between them. Okay. Bye. Take care.